In this video, I'm going to show you how to use the ArcGis toolbox for the LiDAR Python package. The LiDAR Python package is for delineating nested service declarations from digital elevation data. And so here is the GitHub repo. You can go to the URL github.com/gswqs/LiDAR. The link is also in the description below. Once you're on the web page, you can either, if you know Git, you can use a Git clone to download the repository, or you can click the green button and then click download zip to download the repository to your computer. So I'm going to download to my downloads folder. Once it's downloaded, then you can right click to unzip the file. I'm going to just extract here, and it's going to automatically being extracted to the computer. And so this is the entire repository. The ArcGis toolbox is within the LiDAR toolbox. So here is the toolbox, and also all the associated scripts. And so there are also some other Python scripts in here. This is for the non-ArcGis. So you can either, if you know how to use a Python, you can also use a scripting without having to use ArcGis. But for those users without the programming skills, they can use the ArcGis toolbox to do the same thing. So if you are interested in using the scripting, you can click the documentation website to go here, and then you can click the get started to show you how to use this. It also has an interface for you to delineate service declarations without coding. So next, I'm going to show you how we can use this one in ArcGis. Once it's downloaded, we have this one here. You can change the name if you want. So I can maybe just change back to LiDAR. And then I'm going to copy this folder to my documents folder under ArcGis. You don't have to do this. I'm just make it easier because all my projects are under the documents ArcGis. Once it's copy here, you can open your ArcMap, and so you also have this one automatically connected. If this not, you can click the connect folder and then click to your connect to your folder. And so all I need to do is just refresh. Then you should be able to see this one here, and just double click, go to LiDAR toolbox. You should see this one here, and then if you double click, you should be able to see the list of tools within this toolbox. So right now we have the 7 tools in here. Just let you know, so 1, 2, 3, these can be directly executed without installing additional packages. And 4, 5, 6, 7, this we need to set up the environment actually to do this, so it won't work out of the box. And I will, in the next video, I'm going to show you how to install the packages so that we can also run these 4 tools. And so for this video, we're going to go through 1, 2, 3. Okay, and I also provide some sample data. It's under the data folder, and if you are not in this, it's under the examples folder, because the sample data is a bit large, so I don't want to include it in the original Python installation. So I put it under here. So make sure you come here, examples and LiDAR DM. Click this one, LiDAR underscore full.tf. And if you want to build a pyramid, that's fine. So this is the test DM we are going to use. By default, it's grayscale, right? So if you want, you can go to Windows Image Analysis, and I can move this one to the left. Then you just need to click this one, and in here you will see this one here, because we want to use the shaded relief, so it will look much better. So once you click this one, you should be able to see what the DM look like. So there are lots of depressions on the landscape, right? But many of those depressions are nested. And so the purpose of this toolbox is to allow you to delineate the nested hierarchy, not just the maximum boundary, but you also want to delineate what's inside. So in that way, we know how the waters are going to flow when you have when the area is being inundated. So it's not like all at once everything is inundated. It's a process, right? So increasing, and then some depression might merge together. So at the end, when you have enough water or rainfall or snow melt, it's going to be fully inundated. But we're trying to delineate the hierarchy. Okay, so next, let's open the toolbox. Again, go to LiDAR and go to the ArcGis hydrology analyst, and we're going to click the first one, extract sink. So this one is basically allows you to delineate the maximum inundation polygon. So basically, it's also called sink. In GIS terminology, sometimes it's called also depressions. Okay, so but different from the ArcGIS built-in toolbox that allow you to delineate sink. This one give you more options, so you can set a minimum sink size and also the minimum sink depth. You can also do the buffer. So let me show you here the original ArcGIS hydrology toolbox. Where did spatial analyst? And if you scroll down to see here the hydrology sink, right? This one is slightly different. So the sink here, this one you need to delineate the flow direction, and then it has an output raster. But for me, this one here, you can directly get all the just the DM, so you don't need to delineate additional steps. And we can just input this DM. Make sure you select the DM full, not the shaded relief. And then you can adjust the parameters. So in here, it's up to you. The minimum sink size, basically, this spatial resolution of the image is 1 meter. So if you want, you can double click to check the spatial resolution under source, like cell size 1 and 1. And so 1000 means 1000 pixels. So the unit is pixels. So 1 square meter. So it will be 1000 square meter. If you want to delineate a smaller one, you can change this one to a smaller number. But keep that in mind, it depends on the location and your region. If you set to a smaller number, you might end up with a lot of depression. So it might be a lot of artifacts. So you want to play with this number and make sure you find the optimal. If you want a larger depression, you can set it to a larger one. Also the minimum sink depth, right? Basically from the water surface to the spilling point. So again, if you change this one to a smaller one, you will get a lot of a flat area. But if you change to a larger number, then you get a much larger. So the sink depth, this is the vertical unit of the DM. So in this case, it's meter. So we're going to say that, okay, if this the depth is larger than 1 meter, we want to consider this one as a depression. If it is smaller than 1 meter, we consider those as just artifacts. So you are welcome to choose maybe 0.1, 0.5. It's up to you. The next one is the buffer distance. So buffer distance means based on the DM, we're just going to delineate the perfect polygon. But sometimes if you want to do something, you might want to do buffer distance. So in this case, we don't need that. So we can just keep it 0. And then we're going to set the output sink polygon. So we can set this file path. Again, we can go here and then maybe LiDAR. We can create a new folder, maybe called output. Okay. Then double click. Keep in mind, it's going to generate a bunch of files. So we are going to just maybe change the name called sink. Okay. It's going to be a polygon within the output folder. Then just click OK. It should take a couple of seconds, maybe up to 1 minute to delineate. So it's going to go through the whole process to fill the DM and also to delineate the polygon, but also remove those smaller ones. Okay. Okay, so here we have that. You see it's only like 10 seconds and then you get the results. Then we can maybe, let me turn all the data layers off. And just to show you here, this is the DM and this is the sink, right? So maybe you can check this one here to transparent, and then I can maybe change the color to blue color. You should be able to see, right, where those depressions are located. Let me change also the thickness. So much better. So this also shows you all the depressions, right? This is the bigger one, but within the bigger one, you will see that there are some smaller ones, depressions within this bigger one. So this is what we want to do. Use this toolbox to be able to delineate the hierarchy. But this is the first step. So in addition to the polygon, we also have 3 more layers. Okay, so also the sink. So let me show you here the sink. The sink is basically just a subset of the DM, right? The subset of DM that represent surface depressions. Surface depressions are basically all the locations or the area that can hold water, right? So if you overlay the sink on the DM, it will show you in here. But in addition to the polygon, you can also see the elevation of each pixel, right? So 400, for example, 378 to 418, and this one is basically comes from here, comes from this original DM. It's just a subset, okay? And those are non-depression pixels have been removed. Also, we have the other two layers are very important. So the partially filled and also the DM fully filled. So if you look at the fully filled DM, this is the one similar to the ArcGis fill. These two here, this one. So basically fill the surface with water. So basically assume it's fully inundated. And if you overlay the sink on this one, you will see in here. We can also maybe, let me show you here. We can create the shaded relief, and you will know that, okay, it's fully filled. Right after that, you don't see the depressions, right? So compare this one to the previous shaded relief, right? You can see the dramatic difference. That means right now all the depressions have been filled with water, and this is a maximum inundation status you're going to get. If you overlay the sink polygon, right, you will see within the polygon is all flat because right now they are filled with water. There is also another one here called partially filled. Okay, so this is the one that's very important for the next few steps, because earlier when we used the tool, let me come back to here to show you again. We set the minimum sink size and also the sink depth, right? So those depressions smaller than the threshold we specify, those depressions will fill, but the larger one will remain in the DM. So basically we remove those smaller one artifacts. You can think about this one as the refine DM, removing smaller one, keep larger ones, depends on your criteria. Okay, so this is the DM that we're going to need for the next few steps. So I'm just going to turn off this one, and just to show you right now, this is the depression, polygon, and also the shaded relief, and this is the original one. Okay, so the next step is to use the catchment. So basically the watershed, right? Each depression is within a watershed. So there are some portions of the watershed that contribute water to this one. So we can use the delineate catchment tool. And the first one, we need to input the partially filled DM. Okay, so this is the one in here, very important. Select the partially filled DM and also the sink polygon. Okay, so the sink polygon is the first one that developed, and then we can just save the output. So in this one, I'm going to choose the name called catchment, and then just hit OK. It should be able to delineate the catchment for each individual depression. So in that way, we know where the water come from, right? So this is the catchment. Again, you can change transparency to look at where those water come from. So I'm going to change the color and also maybe the thickness to 2. Now you should be able to see clearly, right? For example, for this big depression, the water come from the watershed, right? The catchment within this one and this one, right? So each depression has an individual catchment, and the water, if you have water from here, it's going to flow downstream, and then at the end up within this depression. Once this depression is fully filled, it's going to move the water, flow the water to the downstream. So the next step, what we want is to delineate the flow path. So we want to find out, for example, if this depression is fully filled with water, how is the water going to flow to which depression, right? So in that way, we know the entire flow network within this area. So let's click this one, delineate flow path, and it's different from the previous one. This one we need to fully fill the DM, because in order the water to flow, it need to be inundated. So we're going to use this one, DM fully filled.tif, and again we need the sink polygon. So the range for intensity, this one right now doesn't really matter because we're going to use this one later in the inundation simulation. For now, you can just leave this one as default. It won't affect the flow path. So we can click this one and then save the result, flow path, and then hit OK. So it should take a couple seconds to delineate the flow path for the landscape, and then we will be able to see the flow direction, for example, from which depression flow to which depression. Okay, it's still running, and so for this video, we're just going to go through 1, 2, 3, 4, 5, 6, 7. We will do that in the next video because we need to install some additional packages. Okay, so the flow path is done. Then we can maybe change the symbology. We can add an arrow so in the middle, and then you can hit OK. So now you see some of these in here, for example, right? So if you zoom into this one, this is the flow path. So if the depressions in this one is inundated, once you have enough water, the water is going to come from here and then move to this one. Similarly, right, so from this one is to here, so you can see all the flow paths. Basically, you see the network within this landscape, right? So similarly, if you have depression, this water here, once it's come from here, move to here, and then move to here. So you can see where the water is going to flow from the highest point to the lowest point. Eventually end up with the outlet, right? So the outlet here is not, because the DM is only a subset, so you don't see the final outlet, but you will see that some of those actually floating from the lower elevation, right? So here all the red color represent high elevation, the green and also light yellow, those represent lower elevation, just as you see from the image analysis in here, right? So from high elevation to low elevation. Okay, so this is how you can delineate depressions and catchments and also flow paths. And so the next video, I'm going to show you how to set up the environment to install additional packages so they can delineate the hierarchy and also the catchment hierarchy. Also, you can simulate the inundation. Okay, so this is all for this video. I will see you in the next one.